Hi, so today we have another question in physics in chapter 8, and the number of the question is 8.102, which is one of the big questions about rockets and stuff like that. So the question says, a thorium nucleus at rest decays to a radium nucleus with an emission of an alpha particle. The total kinetic energy of the decay fragment is 6.54 times 10 to the negative 13 joules. An alpha particle has 1.76% of the mass of the radium nucleus. So calculate the kinetic energy for the recoiling radium and the alpha particle. Okay, so first we read the question. Now we need to derive an equation to solve with these numbers. So first of all, we know that the nucleus is at rest, so the momentum equals to 0. So the conservation of momentum is going to be equal to MA VA equals MB VB. So what I mean by A equals alpha particle, and B equals the radium nucleus. Okay, so now we need to solve for B because we already have A. So B is going to be for the VB. VB is going to be equal to MAVA over MB. Okay, so now we know. So one of the formulas that we need to use here is that the kinetic energy of the first one plus the second one equals the decay fragment that we have right here. So Ka plus Kb equals Q, and Q is the decay fragment. So we know that the kinetic energy is 1 over 2 mv squared. So for Kb, we just derived the velocity, so we need to use, instead of Vb squared, we use this equation. So we're going to have 1 over 2 mb Va squared times Ma over Mb squared. It's basically taking this A outside and making it squared to make it easy to calculate. Okay, so now we have a lot of things we can have a common factor between this side. So the common factor is going to be 1 over 2 Ma Va squared. So we're going to cancel this. One of the b's is going to cancel this square. Then the Va is going to cancel with this Va. And the Ma is going to cancel with one of the squared. So we're going to have 1 plus Ma over Mb, which is going to equal to Q. Okay, so now we derive the equation that we need to solve with. But we still need to do simple algebra to help us calculate part A and part B. So part B tells us that the alpha particle, calculate the kinetic energy for the alpha particle. So we know that alpha Ka is exactly like this. So basically we divide this on the other side and we can get the value of Ka. So Ka equals to Q over 1 plus Ma over Mb. So we have the Q as 6.54 times 10 to the negative 13 over 1 plus Ma over Mb, as the question said, is the alpha particle has 1.76% of the mass of the nucleus. So this is the percentage. We're going to change it to decimal, 1.176. So calculating this is going to give us 6.54 times 10 to the power of negative 13 divided by 1 plus 0.0176. This is going to give us 6.43 times 10 to the negative 13. So the answer that we got here is for the alpha particle, part B. So to get part A, it's just simply subtracting what we have, the K fragment, from what we have right here. So we get 6.54 times 10 to the negative 13 minus 6.43 times 10 to the negative 13. This is for KB. So this equals we subtract 6.54 times 10 to the negative 13 minus what we have right here. And this is going to give us 1.1 times 10 to the negative 14 joules. So now we got Ka and Kb. So Ka is the answer for the alpha particle, which is part B in the question, and Kb is the answer for the recoiling radium nucleus, which is part A. So this is how you solve this question. And thank you.